welcome you. As we have seen several exercises in my previous talk, and we will continue to do some other exercises. And again, I am suggesting you don't try to look the proof or the verification of some exercises given here. You try to do by yourself. If you could not succeed, then you check. So, in this way, you will see that whether you can find the solution of the exercises or not. Okay, so the first exercise, today's first exercise is that prove that the metric space PAB, the set of all polynomials defined on the closed interval AB. Okay, so prove that the polynomial with the metric d infinity, which is defined as d infinity fg is equal to maximum of mod of f of t minus g of t, and the supremum is taken over the closed interval AB. So this PAB is not complete. We have already proved that PAB with respect to d infinity or with respect to sup metric is a metric space. So this is a d infinity is a metric we have already seen. Okay, so you have to prove that PAB is not complete. Okay, PAB is not complete. So again, you will have to prove that you will have to construct a sequence of polynomials. Okay, which is Cauchy but not convergent in PAB. So, for the sake of, let us take A is equal to 0 and B is equal to 1. So, we can write P01. Okay, so A is equal to 0, B is equal to, and consider the following sequence of polynomials, that is equal to f and t is equal to summation k runs from 0 to n t raised to the power 2 whole raised to the power k. Means that it is equal to 1 plus t upon 2 plus t n upon 2n. Okay, so you have this is a sequence. This is a sequence of polynomials. Clearly, this Fn is a sequence of polynomials on the closed interval 0, 1 for each n. We show that Fn is Cauchy. Okay, the sequence Fn is a Cauchy sequence. Taking m is less than n, we observe that Fn Fm is equal to supremum overtaking t lies between 0 and 1 mod of Fnt minus Fmt. Okay, by the definition of d infinity matrix. So it is, we can write in this way. But this is what Fnt minus Fmt. So Fnt is equal to k runs from 1 to n t upon 2 raised to the power k minus k runs from 1 to m t upon 2 raised to the power m. So here is m, and now I am taking m is less than n. So up to m, okay, up to m, all the term, because we are taking the difference of this term and this term, they will be 0. So what we will left? We will left only the terms after m. So that is so k start from k plus 1 to n. So k from 1 to n and the t upon 2 raised to the power k. And you can see that if you take because t lies between 0 and 1. So t lies between 0, 1. This is less than or equal to, here is 1 upon 2 raised to the power k. And this, you can see that you can take this is equal to 1 upon 2 raised to the power m minus 1 upon 2 raised to the power m. And this difference is, or you can take it as plus basically. So if this difference, this, okay, so this is the difference. So as mn tends to infinity, this will approaches to 1, this will approach to 1. So it means that as mn tends to infinity, this will approach to 0, and therefore d fn fm, okay, approaches to 0 as mn tends to infinity, and therefore fn is a Cauchy sequence in P01. However, this sequence does not converge in PAB, because you can see that the limit of Fnt, okay, if you will take the limit, okay, Fnt, so if you take the limit as Fnt as n tends to infinity, what you will get? You will get 2 upon 2 minus t. Okay, so you will get 2 upon 2 minus t. So how will you get it? You will get as t approaches to 0. So here is 1, and here is you can take is this one. Okay, and then it is, and but you can see that this is not a polynomial. Okay, so this, the limit of f and t does not lie in P01, and therefore P01D is not complete. Okay, so this way you can prove that the set of all polynomials defined on the closed interval AB is not complete with respect to the submetric. Okay, so now I stop over here, and then we will discuss some more MCQs. Okay, so let us take some MCQs related to this chapter. Okay, so here are some MCQs related to this chapter. Okay, chapter of complete metric spaces. Now, the first MCQ: in a discrete metric space, a sequence can converge to a point only if it is an habitually constant sequence. Or in a discrete metric space, every sequence is convergent. In a discrete metric space, every sequence converges to A to 1. In a discrete metric space, every sequence converges to 0. So here is, you see, this is, okay, here is some misprint. This is the misprint, okay, you can do. So in a discrete metric space, a sequence can converge to a point only if it is an eventually constant sequence. Second is, every sequence is convergent. Okay, every sequence converges to 1. Every sequence converges to 0. So basically the answer of this question is A, only A, not B, C. The answer of this is question A. That is, a sequence can converge to a point in a discrete metric space only if it is an eventually constant sequence. This we have already seen earlier. So you can see that this is so. Now, the second is, in a discrete metric space, every sequence is Cauchy as well as convergent. Every sequence is Cauchy as well as convergent. So it means that every sequence either in Cauchy, all the sequences in a discrete metric space are Cauchy as well as convergent. Every Cauchy sequence, every sequence is Cauchy only, not convergent. Every Cauchy sequence is convergent. None of them. Now we have proved that in a discrete metric space, if you have a sequence which is eventually constant, only then it would be a Cauchy sequence. And of course, as we have seen that in a discrete metric space, every Cauchy sequence is convergent, because the Cauchy in a discrete metric sequence, you will have a Cauchy sequence of the form that x1, x2, xn, and then after this capital N, all the terms would be constant, would be x, 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 x. So it is eventually constant sequence, and therefore you can see that because all after the capital Nth term, all the terms are same, and therefore the xn minus xm is equal to 0. So it is a Cauchy sequence, and of course it has a convergent subsequence, and therefore the sequence will converge to this point. So in a discrete metric space, every Cauchy sequence is convergent, and so therefore a discrete metric space is complete. Now take another example. Another MCQ. So let X is equal to 0 infinity be a metric space with the usual metric dxy is equal to mod of x minus y. Consider a sequence xn in X which is defined as xn is equal to log n for all natural number n, and consider the following statements. One is xn is a Cauchy sequence. Okay. Second, xn is not a Cauchy sequence. The third one is dxn plus 1 xn converges to 0 as n tends to infinity. Then which of the following holds? A, B, that is xn is a Cauchy sequence, xn is not a Cauchy sequence. So A, B cannot hold. So A you can rule out for A, B. Okay, you can already ruled out for A, B. The second one is AC. So AC it is possible. Okay, and the third one is BC. BC means this. This is not possible because if you m is equal to this, so this is not Cauchy sequence, so this cannot hold. So BC simultaneously cannot hold. So BC cannot hold. None of the above. So this cannot hold. So BC cannot hold. Okay, and BC means BC is it is not a Cauchy sequence. So of course, this is not a Cauchy sequence. But you can say the next term of xn plus 1, this converges to 0, but this is not a Cauchy sequence. So these two things, the statement is C, where BC is okay. So C is okay. Now take another example. So here is we have this example. MCQ. Let CAB be the space of all continuous real valued functions defined on the closed interval AB, with the matrices D1 is equal D1 FG is equal to integral A to B mod of f of t minus g of t, and D infinity FG is equal to maximum is taken over closed interval AB mod of f of t minus g of t. That is to say, CAB is the space of all continuous real valued functions, and we have seen that we have two type of matrices. One is the integral matrix, and the second one is the max matrix or the sup matrix or D infinity matrix. And let Fn be a sequence in C01, where Fn is equal to e raised to the power minus nt for all n. Okay, then Fn converges to 0 with respect to the metric D1. Fn converges to 0 with respect to the metric D infinity. Fn converges to 1 with respect to the D infinity. Fn converges to 1 with respect to the metric D1. And now you will see that we have considered this example Fnt in our case. Here you can see we have considered the example Fnt is equal to, where it is gone. We have seen the convergent of the sequence. So we have seen that here is the Fn, the sequence converges to 0 with respect to the matrix D1, but not with respect to the max matrix. So this we have seen. So you can see that here is the matrix. So therefore, this is true. Okay, now take another MCQ. that is, let X be a metric subspace of the metric space R2 with the usual metric. Which of the following is a complete metric space? Now, X is equal to X cross X. Keep in mind, this X is a subspace of R2. Okay? This is a subspace of R2. So, it must be R cross R, X cross. X is equal to X, Z cross Z is the subspace of this. Okay? So, with respect to usual metric. Now, this R cross R, this is your R2. This is your complete metric space. Okay? And this is the subset of this one. So, this is also a complete metric space. Now, here is we have already proved that Z is a complete metric. We have proved that basically set of all natural number is a complete metric space, and in the same way you can prove that it is a complete metric space. So, this is a complete metric space, this is a complete. So, this is a complete metric space of this with respect to the usual metric. But Q, we have seen that is not complete metric space. So, this as X as a X is equal to Z cross Y as a subspace of R cross R is not a complete metric space. So, this is not a complete metric space. It means that this cannot hold good. And similarly, instead of this set of all irrational numbers, it is set of all irrational numbers is not complete metric space. So, it is not complete metric subspace, and therefore Z, however, Z is complete, but this is not complete. So, this is not complete subspace of R cross R. And again, this set of natural numbers is complete, but set of rational numbers is not complete, and therefore this as a subspace of R cross R is not a complete subspace. So, this way you can prove that the answer is A. Okay. So, here is the answer is only A. Now, take another MCQ. So, suppose XD is a metric space, D star and D lower star are two matrices which are defined in this way, and we have seen that these two matrices are these two, D star and D lower star, matrices on the space X. So, if Xn is a Cauchy sequence in X, then it is a Cauchy sequence with respect to this, but not Cauchy sequence with respect to this. Number one. Number two, it is a Cauchy sequence with respect to this, but not Cauchy sequence with respect to this. It is a Cauchy sequence, okay, neither is a Cauchy sequence in D. Okay, so if you have a Cauchy sequence in D, then it is not neither a Cauchy sequence in with respect to this D and with respect to this D, and it is a Cauchy sequence in this as well and in this one. Okay, so what would be the answer? The answer is your D, because you can see that if it is a Cauchy sequence, okay, you can see that you can prove that from here. You can prove that if Xn is a Cauchy sequence with respect to D, then it is Cauchy sequence with respect to this one. Similarly, if a sequence is a Cauchy sequence with respect to this D, then it is Cauchy sequence with respect to this D star. And so, you have the answer is the correct answer is your D. Okay. Now, let us take another exercise MCQ. Which of the following statement does not hold? Okay. Which of the following statement does not hold? The set of integer with the usual metric space is a complete metric space. Yes, it is true. Okay. Every discrete metric space is complete. Yes, it is true. The space of all rational numbers Q with the usual metric space of absolute value is not complete. Yes, it is true. the metric space X is equal to 0, 1 with the usual matrix is complete. No, it is not complete. As we have seen that you can consider a sequence Xn is equal to 1 over n, okay, in the space S, which is a Cauchy sequence, but it is not convergent because it converges to 0 and 0 is not an element of this set, and therefore this the last statement that is to say D is not hold good. Okay, so basically you can see that you can have several other okay. Let's take another MCQ. So, which of the following statement does not hold? Again, CAB, the space CAB of all continuous real valued functions defined on the closed interval AB with the D infinity matrix or with respect to the max matrix is a complete metric space. Okay, CAB with respect to this is a complete metric space. Okay, and this is true. We have proved that this statement is true, but CAB is not complete with respect to the integral metric. Okay, so this is okay. The CAB is not complete with respect to the integral metric. Yes, this is also true. CAB is complete with respect to the max metric, and CAB is not complete with respect to the integral metric. So these first two are true. Take the space of all natural numbers with dxy is equal to this is complete with dxy is equal to mod of 1 over x minus 1 over y. This is a complete metric space. So this we have proved. So this we have proved that the set of all natural numbers, here we have proved that the set of all natural numbers n with respect to the metric dxy is equal to 1 over x minus 1 over y is not complete. So here is you can see that this statement is not true. Okay, and the same time, so we have proved that the set of real numbers with respect to this metric is not complete, and this we have also proved that set of here is we have in the exercise we have proved that this xd, this x is equal to r with the matrix D is not complete. So here is you can see that this is not complete. So this statement is true, but this statement C statement is not true. So this way you can see. Now take another MCQ. Let's take A is equal to this set with the usual metric on R and PAB with the space of all polynomials defined on AB with the uniform metric or submetric. Okay. Then which of the following statement is true? Number one, A is not complete. Okay. But the metric space PAB is complete. Okay. We have seen that PAB is not complete. Okay. And A is not complete. Okay. So statement A is not true. Now A is complete, but the metric space PAB is not complete. No, it is not. A is not complete. We have seen that A is not complete. This we have seen. You see that here you can see that this is not complete with respect to the usual metric on R. So this is you see have this. Okay. No. Sorry, there is something wrong in this one. There is something wrong in this one. Okay, so discard this question number 10. Take question MCQ question number 11. So, which of the following set X is a complete metric space with respect to the usual metric on Rn? Okay. So, you see here is a Z, this is called complete. Okay, so this is a complete metric space as usual metric, but Q is not complete, and therefore this is not a complete subspace of R2. Again, this is not complete, and even this is also not complete. So both are not complete. So this is not complete subset of R cross R, and also this is not complete subset of R, and this, because this set is complete, this is closed, this set is closed, and here is you see that this set of all irrational numbers, but this is not closed. This is not complete. So this is not complete. So only the answer is your A. So rest of the questions are not closed. So here is there were several MCQs we have seen. So basically you have seen that most of the MCQs and other results. MCQs can be, you can also construct by your own by looking towards the exercises, towards the examples, towards the results or the definitions. So you can also prepare the several MCQs by your own, and you can see that how one can manipulate, one can confuse you to write, or how can you confuse to the other people to write a question in the form of any MCQ. So basic idea is in the MCQs to just to confuse to the pupil, okay, and rest is other things are fine. There is nothing else. So just you discard this question number 10 because there was some problem in this question. So this is not correct. So just you discard this one. Okay. So now I stop over here and thank you very much.